Both evaporative and water-cooled condensers utilize water in the heat transfer process. Therefore, water treatment is a subject that a refrigeration professional must be familiar with. Water treatment is the process of managing and improving the quality of water circulating within a condenser or cooling tower to optimize its performance, minimize maintenance, and extend the lifespan of the equipment. Condensers use water as a heat transfer medium, which exposes the equipment to risks such as scaling, corrosion, fouling, and biological growth. Effective water treatment helps a refrigeration system to operate efficiently and reduce downtime. There are several objectives to any water treatment program. First, a good water treatment system will prevent scaling. Scaling occurs when dissolved minerals such as calcium and magnesium precipitate out of the water and form deposits on heat exchange surfaces. This reduces heat transfer efficiency and increases energy consumption. Studies have shown that 1/32 of an inch of scale on a condenser tube reduces the heat transfer capability by as much as 30%. This reduction in performance caused by scale buildup is often referred to as fouling. Second, water treatment controls biological growth. Cooling towers and condensers provide ideal conditions for microbial growth, including algae, bacteria, and fungi. Effective biocide programs prevent biofouling, which can grow on surfaces, degrade system performance, and become a danger to human health. Third, water treatment helps control corrosion by maintaining optimal pH levels. Fourth, water treatment allows for higher cycles of concentration, reducing the need for makeup water and minimizing blowdown, thereby conserving water and reducing operational costs.
When talking about evaporative condensers, we typically don't want to use the pumps as a means for kind of controlling the head pressure. We want to keep the pumps running as much as possible so that the surface of the tubes stays wet. If we start cycling our pumps on and off, it will change the condensing capacity of the condenser. It will achieve that desired result, but there will come with a dramatic downside, which is mineral and scale buildup on the tubes of the condenser. So keep in mind that almost all water has some amount of minerals in it, right? Calcium, magnesium. And when water evaporates, it's only that pure water, the H2O, that evaporates. And what's left behind are those minerals. So those mineral deposits, kind of that white scaly look that can form on a household appliance or something, that's what happens to the tube. You might think, well, what's the big deal? But it's actually a really big deal because 1/32 of an inch of scale, think how small that is. 1/32 of an inch can reduce the capacity, the heat rejection capacity, as much as 30%. So this is not something we want to mess around with. So for that reason, pretty much always keep the pumps running, or if you do want to shut it off, it's done in a strategic way, meaning we're gonna drain the sump, turn the pumps off, and it'll probably be off for a long period of time. It's not something we're gonna cycle on and off.
There are many methods used in a water treatment program. Methods will vary based on the quality of the water available at the site where the condenser is installed. Most water treatment programs utilize chemicals to precisely manage water quality. Anti-scaling agents are additives that inhibit mineral precipitation, preventing scale formation. Corrosion inhibitors are chemicals such as phosphates or molybdates that form a protective layer on metal surfaces to prevent corrosion. Biocides such as chlorine and bromine kill microbes by disrupting their cellular functions. Acids or alkaline substances are added to maintain pH within an optimal range, which is usually between 6.5 and 9, to balance corrosion and scaling risks. Passivation is a specialized chemical treatment process used to form a protective passive oxide layer on galvanized steel surfaces. New condensers constructed of galvanized steel must be passivated before being placed in full operation. Passivation involves circulating water with a pH between 7 and 8.2 for 4 to 8 weeks, or until new zinc surfaces turns dull gray in color. Proper execution of passivation contributes significantly to the lifespan of an evaporative condenser. Condensers using stainless steel tubes do not require passivation. Blowdown is employed to remove a portion of the water with high concentrations of dissolved solids to prevent scaling. In situations where chemical treatment is not used, blowdown should be continuous. Total dissolved solids should not exceed 1,500 parts per million. Blowdown rates can also be automated by using sensors that monitor conductivity levels in the water. A water softener can be used to reduce the hardness of the makeup water. A softener accomplishes this by removing calcium and magnesium ions, which are major contributors to scaling. Water hardness should be maintained between 30 and 750 parts per million of calcium carbonate. Filtration is used to remove debris, dirt, and other suspended solids from the circulating water. Periodic cleaning is essential to remove accumulated biofilm, dirt, debris, and scale that forms on surfaces. Most facilities hire a qualified water treatment professional to oversee the water treatment program. However, every refrigeration professional must know how to monitor the program. The key parameters to monitor are: conductivity indicates the concentration of dissolved solids. High levels signal a need for blowdown. Maintaining a proper pH helps minimize corrosion. Water hardness tracks calcium and magnesium levels to prevent scale buildup. Microbial activity monitors biological growth and the need to adjust biocide dosing. In conclusion, water treatment for condensers and cooling towers is essential to ensure efficient system operation. By preventing issues such as scaling, corrosion, and biological growth, a well-designed water treatment program maximizes system performance, conserves water, and extends the lifespan of equipment.